Hello everyone, my name is Rohit Rokade, and today me and my team will be presenting a PowerPoint on the topic parallel processing. So yeah, before we begin, here is the introduction page. So what I'll be basically doing is giving a rough idea about everything about today's topic and tell you about the agenda of today's topic and what we are planning to achieve. So basically what we are trying to achieve is like explaining rough layout of entire parallel processing unit. So that typically includes like what is parallel processing, how is it done, its benefits, types of parallelism, and so on and so forth. Guys, now let's begin with our PPT. So the very first topic is what is parallel processing. So before I actually begin with this topic, all you need to understand the basic function of a CPU, and that is to process data. So now in order to solve that particular data, a CPU uses two methods or two kinds of processing. One is serial and one is parallel. Now serial processing is typically an old kind of processing where typically what happens is the CPU actually solves only one data at one particular moment of time, which means like if you are running multiple data at a single moment of time, the amount of time required to process that many data is increased hugely. So in order to overcome this, we have come up with something called as parallel processing. What basically happens in parallel processing is, the CPU basically distributes the data or breaks down the data into different parts and then distributes to different parts of the CPU itself and process it and then reassemble it and create a meaningful data or a meaningful output. Now moving on to next slide. So the next slide is how parallel processing works. So typically a computer scientist will divide a complex task into multiple parts with a software tool and assign each part to a processor. Now what that typically means is when you are basically running a very huge code, I mean like absolutely huge code, you cannot rely on only one particular code.
Hello everyone, I am Rajwardhan Rokade here to explain types of parallelism. There are four types of parallelism. First one is bit level parallelism. Second one is instruction level parallelism. Third one is task parallelism. Fourth one is data level parallelism. Now let's see first one, bit level parallelism. Basically, bit level parallelism is a form of parallel computing which is based on increasing processor size. It helps to reduce the number of instructions which are given by a system to execute the task. For example, if we compute the sum of 16-bit integers by 8-bit processor, it requires two instructions, but it takes only single instruction by 16-bit processor. Let's shift on the next type.
I am Rohan and I am going to explain the topic which is task parallelism and data parallelism. Task parallelism is a form of parallelization of computer code across multiple processors in parallel computer environment. Task parallelism focuses on distributing tasks concurrently performed by processors or threads across different processors. And the next one is data level parallelization. Data level parallelization is an approach to computer processes that aims to increase the data through by the operating on multiple elements of data simultaneously.
Now, moving on to next, there are four types of parallel processing. First one is SISD, means single instruction, single data system. Second is SIMD, single instruction, multiple data system. Third is MISD, multiple instruction, single data system. And fourth is MIMD, that's multiple instruction, multiple data system.
Hello everyone, I'm Rohitashva Kumawat here to explain SISD and SIMD. Starting with SISD, it stands for Single Instruction Single Data Systems, where we give single instruction to the process which is carried out in sequential manner and stored in primary memory. Coming next with SIMD, it stands for Single Instruction Multiple Data System. It is capable of executing the same instruction parallelly, and machines based on SIMD like it used for scientific computing since they involve lots of vectors and metric operations. Coming with an example, so supercomputers are used in astronomy, so they gather a lot of information about the cosmos and store it somewhere, but it is hard to process them sequentially, serially, so we use parallel processing here.
Now, MISD means multiple instruction, single data. In MISD, there is one data source, one data pool, and same data. The single data gets to the processors. But each processor runs a separate instruction pool on each data provided to this processor. This is very specific and it isn't widely available or widely used. As MISD is mostly used when you get in situations where you need to double check the data to ensure that the outcomes are as expected. Its main usage is in space shuttles, as there's the need of real-time error detection on flight system, as it shouldn't malfunction in between. It is also used in modern avionics or jets and planes. But it has an disadvantage that it has a very limited use, so it ain't available commercially. Now, this brings us to MIMD. Now, what is MIMD? MIMD means multiple instructions, multiple data. As the name suggests, here we have an instruction pool, a data pool, and multiple processor units. And all these multiple processors taking different instruction and working on these different data at all same time. This means you can process a lot of data and a lot of instruction at same time. It's great at the situation of multitasking. As you all know, all the mobile laptops, modern electronics uses multiple tasking. As it multitasks, its architecture becomes complicated and hence it becomes more expensive to produce.